Okay, so this is the first question. The molecular geometry of SF4 is octahedral. And what is the geometry of, see, SF6 is octahedral, right? So SF6, in SF6, these are the 6 fluorines in this way. So this is octahedral shape. Now in SF4, how many bond pairs are there? Respond fast. There are 4 bond pairs, and how many lone pairs? How many lone pairs are there? But of fluorine, 4 electrons are used, and sulfur has total 6 valence electrons. Out of 6 valence electrons, 4 are used. So 2 left unshared. Therefore, there is 1 lone pair. 4 bond pairs and 1 lone pair. Total 5 electron pairs. So 5 electron pairs, they are like this because lone pair always occupy equatorial position. So its shape is seesaw, but its arrangement, its geometry is trigonal bipyramidal. Arrangement, see, it is written what is the geometry of SF4 including lone pair of electrons. So one of the position is occupied by lone pair, and total arrangement of bond pairs and lone pair is trigonal bipyramidal. Okay, so this is question from 2020. Next question. The shape or structure or XCF4, sorry, XCF5 1 negative and XCO3F2 respectively are. So see, in XCF5 1 negative, how many bond pairs are there? There are 5 bond pairs. Am I right? There are total 5 bond pairs. Now, tell me how many lone pairs are there? Yes. How many lone pairs? So say total 8 electrons, 8 valence electrons with xenon, and 1 electron is gained. So total 9 electrons. Due to negative charge, 1 electron is added in the valence electrons. So total valence electrons are 9. Out of 9 valence electrons, how many valence electrons are used? 5. So 5 electrons are used. So how many left unshared? How many electrons left unshared? 4. So 2 lone pairs. So 5 bond pairs and 2 lone pairs. And XCO3 F2, how many bond pairs are there? Again 5 bond pairs, 3 oxygens and 2 fluorines. So 3 oxygens used 6 electrons, 2 fluorine used 2 electrons. So total 8 electrons are used, and xenon has 8 electrons only. So no lone pair. That means XeO3F2 is trigonal bipyramidal. So see, trigonal bipyramidal, there is only one, okay, two options are there, trigonal bipyramidal, trigonal bipyramidal. So out of A and D, we have to see. Now there are 5 bond pairs along with 2 lone pair. That means trigonal bipyramidal shape cannot be possible. So that means A option is only possible. Pentagonal planar, because 2 lone pairs, they are occupying symmetrically above and below the plane. Pentagonal planar. That's why it is pentagon. 5 fluorines are on the pentagon. That's why it is pentagonal planar. So option A is correct. Why it is pentagonal planar? Due to the symmetrical arrangement of lone pairs. Okay. Next, compound that has the largest HMH bond angle. So in H2O, tell me how many bond pairs are there and how many lone pairs are there. Oxygen is central atom, so 2 hydrogens are attached. That means 2 bond pairs. And tell me how many lone pairs. Again 2 lone pair, because oxygen has total 6 valence electrons. Out of 6 valence electrons, 2 are used. So 4 electrons left unshared. So 2 lone pairs. Same is the case with H2S. 2 bond pairs. Sulfur again has sulfur again has 6 valence electrons. So 2 lone pairs. Now NH3. Yes, but in NH3, how many bond pairs and lone pairs are there? 3 bond pairs and 1 lone pair, because nitrogen has 5 valence electrons. Out of 5, 3 are used. So we left with only 2 unshared electrons. So 1 lone pair. And what about CH4? Four bond pairs, and carbon has 4 valence electrons only. All the 4 are used. So 4 bond pairs, no lone pair. So in H2O there are, see, total pairs are 4 only. In all the cases, total pairs are 4. So all have tetrahedral arrangement, but number of lone pairs are different. In H2O, H2S, number of lone pairs are equal. So according to valence shell electron pair repulsion theory, what is the relation? Lone pair repulsion is more than lone pair bond pair repulsion, which in turn greater than bond pair repulsion. This is the order of repulsion. So in first case, in CH4, there are only bond pairs. So all bonds are regular bonds, that is 109 degree 28 minute, and this shape is known as tetrahedral. What about ammonia? To say due to the presence of lone pair, lone pair repel bond pair more, so bond pair come closer, so angle between the bond pair decreases. So in case of that methane, there is 109 degree 28 minute angle, but in ammonia it is 107.5 degree, sorry, 107 degree, very close to 107 degree. Now come to H2O. Say carbon, nitrogen and oxygen, they belong to the same period, so we can compare them like that. So in H2O, there are two lone pairs. So there is lone pair repulsion, and these lone pair repel bond pair. So bond pair come more closer. So angle is 104.5 degree. So keep in mind, if atoms are of the same period, bond angle is inversely proportional to number of lone pairs on central atom. Okay, as lone pair increases, bond angle decreases. Just note down this part. Bond angle is inversely proportional to number of lone pairs on central atom. H2A, in H2A, sulfur belongs to third period, sorry. So as H2O and sulfur belongs to third period, its angle is very, very less. I will send you a video of bent rule. Sulfur, phosphorus, in these cases, angle is almost 90 degree. It is, I think, H2S, in H2S, it is 92 degree around. Yes, you can check. It is around, means very close to 90. Means in these cases, p orbitals are used for bonding. But just keep in mind, see, there is no lone pair in methane, that's why its angle is largest. So D option is correct. Next question. The dipole moment of CCl4, CHCl3, CH4. Yes, but what is the order of dipole moment? Yes, beta. In CH4, 4 bond pair, no lone pair. In CCl4 even, 4 bond pairs, no lone pair. In CHCl3, again 4 bond pairs, sorry, 4 bond pairs, no lone pair. So what is the dipole moment of methane? So I will write the rule. What is the rule? Rule is molecules having only bond pairs and all bond pairs are of same type. These molecules have zero dipole moment and are non-polar molecules. Okay, so see, in methane there are only bond pairs and all bond pairs are of same type, so dipole moment is 0. In CCl4 all are bond pairs and all bond pairs are of same type, again dipole moment is 0. But in CHCl3 there are only bond pairs, but bond pairs are of different type. 3 CCl bonds are there and there is one CH bond. One bond is different from the other 3. That's why it is polar and its dipole moment is not equal to 0. So what is the relation between dipole moments? Methane and CCl4 have equal value and that is less than CHCl3. So D option is correct. CH4 and CCl4 both are non-polar and their dipole moment is 0, and that is in CHCl3 it is greater than 0. Not equal to 0 means it is greater than 0. It can never be negative. So D option is correct. Again, question from 2020. Next question. These are the questions from 2021. JEE Main 2021. The correct shape and III bond angles respectively in I3 negative ion are. So we have I3 negative. So treat I3 negative as I2 negative. Keep in mind, whenever same type of atoms are there, one of them should be taken as the central atom. So iodine, one iodine that is taken as central. Okay. And so how many bond pairs are there? Around central atom there are how many bond pairs? 2 bond pairs. So tell me how many lone pairs are there? So tell me how many lone pairs are there in I2 negative? There are 3 lone pairs. Why? Because iodine has 7 valence electrons. 1 electron is gained, so total 8. Out of 8, 2 are shared. So 6 electrons left unshared. So 3 lone pairs. 2 bond pairs and 3 lone pairs. So, and now see, total 5 means trigonal bipyramidal arrangement. So there are axial and equatorial bonds. So tell me, where will be the lone pairs? Yes, beta. Tell me. They are on the equatorial position. They are on the equatorial position. Okay. They are on the equatorial positions. Okay. So three lone pairs are there. So there are three lone pairs and two bond pairs on axial position. So in this way, it is linear in shape and angle is 180 degree. Okay. Right. So third option is correct. Now come to this. Which of the following is are isostructural pairs? So let us start with D. BCl3, BrCl3. So in BCl3, there are three bond pairs. How many lone pairs? Yes, beta. How many lone pairs are there in BCl3? In BCl3, there is no lone pair because boron has three valence electrons. All the three are used, so no lone pair. But in BrCl3, again there are three bond pairs. But how many lone pairs? Yes, beta. How many lone pairs are there? Bolo beta. Hmm? There are beta seven electrons, valence electrons of bromine. Three electrons are used. Four electron left unshared. So two lone pair. Very good. That means they are not isostructural because bond pair and lone pair should be same. Now come to ammonia and NO3 negative. In ammonia, how many bond pairs are there? Three bond pairs. And nitrogen has five valence electrons. So out of five, three are used. So one lone pair. But in NO3 negative, there are three bond pairs. And how many electrons are shared? Six. Because each oxygen need each oxygen requires how many electrons? Two electrons. So three oxygen requires six electrons. Nitrogen has five valence electrons. One electron is gained to six electrons. So all the six are used. No lone pair. That means this pair is also not isostructural. SiCl4. Four bond pairs, no lone pair because silicon has four valence electrons only. So no lone pair. What about TiCl4? 4 bond pairs, and how many valence electrons are there in titanium? So you see, titanium is, yes beta, titanium 4s2 3d2, 4s2 3d2, 4 bond pairs and no lone pair, right? But in SO4 2 negative, again 4 bond pairs, no lone pair. In CrO4 2 negative, again 4 bond pairs, no lone pair. But keep in mind SO4 and Cr. See, in silicon there is a use of S and P orbitals. We use only S and P orbital. Hybridization is sp3. But in titanium, it uses 3d and 1s. So it is d3s. But in this case, SO4 2 negative, again sp3. So which pair is same? B, A and B. Because they have 4 bond pair, no lone pair, 4 bond pair, no lone pair. Again 4 bond pair, no lone pair. In all the cases, so A and B pairs are isostructure. So option 2 is correct. Okay. Next. The oxide which contains an odd electron at nitrogen atom. We have done limitation of octet rule, which has an odd electron at the nitrogen. Yes, beta. Tell me. Beta NO2. In N2O, NO and NO2. NO and NO2 both are odd electron molecules. Here its shape is like this. NO2, one odd electron is there. In NO2, there is one odd electron. So option 2 is correct. If you go through the limitations of the octet rule, you will get it. Okay. Okay. Now, next question. Number of species below have 2 lone pair of electrons in the central atom is. So SF4. How many bond pairs and lone pairs are there? 4 bond pairs. And how many lone pairs? Very good. 1 lone pair. Second one. BF4 negative. How many bond pairs and lone pairs are there? Again 4 bond pairs And how many lone pairs? No lone pair. Beta, boron has 3 valence electrons, okay, and 1 electron is gained. So 3 plus 1, 4 electrons boron has in the valence shell after gaining 1. Okay, see the configuration of boron: 1s2, 2s2, 2p, 1. So there are 3 valence electrons and 1 negative charge. Because of that, 4, and all the 4 are used. So no lone pair. Come to ClF3. How many bond pairs are there and lone pairs are there? How many bond pairs and lone pairs are there? So 3 bond pairs. And how many lone pairs? See, chlorine has 7 valence electrons. We will see the valence electrons of the central atom. So chlorine has 7 valence electrons. Out of 7, 3 are used. So 4 left unshared. So 2 lone pairs. So this is the one which has 2 lone pairs. Now come to ASF3. In ASF3 again 3 bond pairs, and arsenic, it belongs to this series. Nitrogen family. This is the nitrogen family. Okay, तो मैंने ऐसे याद रखा है, न्यूज पेपर आज सब बिकेगा। और क्या होता है, नाना पाटेकर और सरानी सब बिकाऊ, ऐसे करके लोगों ने याद किया है, वैसे भी कर सकते हो आप। तो नाइट्रोजन फैमिली में आर्सेनिक है। सो इन नाइट्रोजन फैमिली देयर आर 5 वैलेंस इलेक्ट्रॉन्स, out of 5 3 are used, so 2 left unshared, that's why it has 1 lone pair. Now come to next, PCl5. In PCl5 again phosphorus valence electrons 5, and all the 5s are used by chlorines, so 5 bond pairs but no lone pair. What about BRF5? In BRF5 how many valence electrons are there? Sorry, how many bond pairs are there? So 5 bond pairs. And how many lone pairs? There is 1 lone pair, because bromine has 7 valence electrons. Out of 7, 5 are used. So 2 electrons left unshared. So 1 lone pair. Now HCF4. There are 4 bond pairs, and xenon has total 8 valence electrons. Out of 8, 4 are used. So how many left unshared? 4. So 2 lone pairs. Again there are 2 lone pairs, because we need those species having 2 lone pairs. Now last one is SF6, 6 bond pairs, and sulfur has 6 valence electrons. उस से डेपो, ऐसे याद रखना, उस से डेपो. So no lone pair. That means there are only 2 number of species that have 2 lone pairs in their central atom, that is 2. So integer based question है, ठीक है? So 2 आंसर आएगा. Okay, among the following linear species is इनमें से लीनियर स्पीशीज कौन सा है? NO2 का स्ट्रक्चर अभी पढ़ा था हमने। देखो NO2 में देखो कैसे निकालना है। There are 2 bond pairs. So how many electrons are used? 4. 4 electrons are used. If 4 electrons are used, nitrogen has 5. So there is one, not a lone pair, but one lone electron, or we can say one unshared electron. In Cl2O, oxygen is central atom. So 2 bond pairs, because 2 chlorines are attached to oxygen. So total valence electrons or oxygen are 6. Out of 6, 2 are used. So 2 bond pairs, 2 lone pairs. O3. So O3 is written as OO2. So again OO2, there are 2 bond pairs. Total electron used are 4. Because one oxygen uses 2 electrons. So in the central oxygen, there are 6 valence electrons. Out of 6, yes, beta, out of how many are used? 4 are used. So how many left? 2 electron left unshared. So one lone pair. Okay. But in N3 negative, take it as again as NN2 negative. 2 bond pairs. And how many lone pairs? Say nitrogen uses 3 electrons. So total electron used by 2 nitrogens are 6, and nitrogen has 5 valence electrons and 1 negative. So 6 valence electrons. All the 6 are used. So no lone pair. See the difference. In oxygen it is 1s2, 2s2, 2p4. 2 electrons are required to complete its octet. In nitrogen it is 1s2, 2s2, 2p3. So 3 electrons are required to complete its octet. That's why nitrogen, each nitrogen uses 3 electrons. So that means 2 bond pairs, no lone pair. That's why it is linear. If there are only 2 bond pairs, there should be a maximum angle between them, and that's maximum angle between 2 bonds is 180 degree, and that's why it is linear in shape. So N3 negative is the right option. Next, a central atom in a molecule has 2 lone pairs of electrons and forms 3 single bonds. So what is the shape? Yes, beta. Fast. 2 lone pairs and 3 single bond means 3 bond pairs and 2 lone pairs. So total 5. And you know arrangement is trigonal bipyramidal. Arrangement is trigonal bipyramidal, but it talks about the shape. Trigonal bipyramidal is the arrangement when we arrange them. Let us say it is A central atom, bond pair is written as B and lone pair as L. So A, tell me where I will put the lone pairs, on the axial positions or equatorial position. Yes बेटा, लोन पेयर कहां पे आएंगे, एक्सियल पे या इक्वेटोरियल पे? Yes, they should be on the equatorial position. So 2 lone pairs on the equatorial position, and we left with 3 bond pairs. It is like this. These 2 bonds, axial bonds, are slightly bent. So it is bent T shape, but we can write it as T shape, but in actual it is bent T shape. but generally we call it as T-shaped. So it is T-shaped. Option number 3. Again, questions from 2021. This one, I think we have done it in the last lecture. Yes, beta. We have done it or not? I think so. Up to this we have done last time. So this is all about today's session. These are questions today from 2020 and 2021 JEE main, or these questions belongs to VSEPR theory and very few questions of dipole moment. In the next session, we will cover hybridization and MOT. For those MOT, I will share the videos. Okay, that's all. But I think you have not done what is expected from you all. Okay, so